Good day, everyone. I am Engineer Azeneth Baguhin of Cagayan de Oro City Water District, and my co-researcher for this paper is Dr. Ruth Ginita Cabajo of the University of Science and Technology of Southern Philippines. The contents of this paper or the presentation are the background of the study area, the objective of the study, methodology, the results and discussions, and finally, the conclusions and the recommendations. Water loss has been a global problem in most of the water utility companies throughout the world. Not only will it possess economic loss, but it affects the level of water service to the consumers as well. So since water losses are the main components of NRW therefore is an indicator of systems water losses. There are 85 countries over the world who are encountering high NRW in their water system operations. Now, because of the multi-looping pipe network set up in most of our water systems, it is difficult to quantify accurately the amount of NRW components. Hence, this study has been undertaken in order to illustrate effectively the NRW components using DMA. DMA, or the district metered area, is defined as a discrete area of a water distribution network. Area of study is located within the western part of Cagayan de Oro City. The said area is named as the DMA1 because of the reason of confidentiality, and this area has approximately 634 connections. The objective of the study is to quantify the real loss components of the study area, DMA1, using the district metered area approach. For the methodology, the methodology involves identifying the baseline, quantifying real losses through the minimum night flow, and determination of current real losses, as well as the determination of unavoidable real losses. The next step will be the establishing of the water balance. And after establishing the water balance, the next step will be the determination of the non-revenue water and the determination of its real loss components. The next step will also be the interpretation of the DMA data, the step test, the leak detection and repair, and finally the water loss reduction. Now, the formula for quantifying the current real losses, or the CRL, is through the use of the equation number 1 and equation number 2. Now, in order to get the CRL during the minimum night flow, this will be computed through the equation CRL at minimum night flow is equal to flow during the minimum night flow less the residential night consumption and the residential leakage. Now please take note that the CRL or the leakage will vary over the 24-hour period during the day, since the pressure will vary according to the 24-hour time pattern. So, if we'll get the CRL at any time of the day, it has to be multiplied with the night-day factor. The night-day factor at any time is equal to the pressure at any time of the day over the pressure during the minimum night flow raised to the power of N1. Now this N1 is the leak exponent, and this will vary from the values of 0.5 to 1.5, which is being close to 0.5 if it is fixed area path, which means that the pipe material is rigid, and the value of 1.5 if it is a variable area path, which means the material is made up of PVC. URL, or the unavoidable real losses, is the lowest level of leakage achievable, so it is computed through the use of equation number 3. And in the same manner, the URL at any time will be computed by multiplying the URL during the minimum night flow times the pressure at any time of the day over the pressure during the minimum night flow raised to the power of N1. In establishing the water balance, you have to compute the NRW. Now take note that in this method, the component that we first quantify is the real loss component. The apparent losses can be computed then by the use of equation number 6. Then, after having quantified the real loss component, we already know that a certain level of leakage has to be recovered. So we need to conduct a step testing activity in order to determine which segment within the DMA area possess much of water losses or the leakages. The result of the step test is now the basis for leak detection. During this stage, leakage points will be localized and be pinpointed. After having the leak detection activity and the probable location of leakages had been marked during the leak detection, the area now is ready for excavation and exploration in order to locate the actual leaks. And lastly, water loss reduction has been now being monitored since the DMA area is capable of monitoring its inflow volume. Now this is the result of DMA1. The pressure of the DMA has to be assessed on the onset. And since DMA1 has a PRV component or a pressure regulating valve, the PRV is preset to control the pressure during the period where the demand is low. And by applying the formula illustrated in the methodology, this is now the graph of the CRL. This is now the water balance of DME1 before the intervention. It has an NRW of 9,369 cubic meter per month and a real losses which comprised of 88% of the NRW component, or it has an 8,249 cubic meter flow rate. So in other words, the ME1 possess a high volume of leaks. Step test is being undertaken in the area. This can be done by progressively closing the valves per segment, and corresponding drop of flow has been recorded. The result shows that segment 1 has a high volume of flow drop, and after having computed the theoretical leakage volume, leak detection and repairs were undertaken in the area. This resulted to the decrease of the CRL in DMA1, which has been clearly shown in the graph. After the intervention, the water balance and the real loss components has been quantified again, and effectively, the NRW get lowered from 9,369 cubic meter per month to 6,390 cubic meter per month. This is due to the reason that the real losses has been decreased from 8,249 cubic meter per month to 6,171 cubic meter per month. As a conclusion, the assessment of real losses using the minimum night flow analysis through a DMA approach is very effective since after repairs at segment 1, the NRW of the DME1 decreases. That is, the rate of NRW reduces from 9,369 cubic meter per month to 6,390 cubic meter per month, or from 45% reduces to 34%. As for recommendation, first, it is recommended to continue the real loss reduction at the DME1 in order to check if there are still leakages in the area. Second, it is also recommended to conduct another step test in order to re-evaluate the leakage level of the DME1 if there are still existing leakages in the area. Additionally, to validate my findings, top-down assessment of water losses can be used to quantify each component of NRW. Remember that through identifying exactly the real loss component of the NRW, it is obvious that there can be a bigger opportunity for real losses to be recovered. And by that, the ME1 can be economic and efficient district metered area a water utility can be. And that ends my presentation. Thank you very much.